Welcome to Patch Math, where today we are going to solve systems of linear equations with the elimination method. We are going to solve this problem by adding the equations together and combining like terms. In this case, negative 4x plus 4x goes to 0x, which is just 0, and we cancel that out. If you want to write 0 here, you can, but you will find it won't affect your answer. Again, we are going to combine negative 2y plus 8y. That is 6y. So this is plus 6y, or positive 6y. And you'll notice 6y plus 0 there is just 6y, so it can go away. From there, we have negative 12 minus 24. In this case, that is negative 36. And now we have a single equation with a single variable y, and we can solve for it. We are going to solve for y by doing the opposite operation of how that coefficient is attached, and it's attached by multiplication. So we are going to divide it off from each side. What we do to one side of the equation, we must do the exact same thing to the other in order to retain the original value of the equation. In this case, 6 divided by 6 is 1, and 1y is y. And so y is equal to negative 36 divided by 6. Negative divided by a positive is a negative, and this is equal to negative 6. We are not done. We have to find the x that goes with this y. Fortunately enough for us, we can choose either of the equations that we started with. And I prefer the first one, honestly, even though it has a bunch of negatives. I feel like it's going to result in smaller numbers. So I'm going to go ahead and bring that on down. If you recall from the graphing video, the solution to all systems is where the graphs intersect. We are finding a point of intersection. So it does not matter which equation we substitute the y that we just found, negative 6, into. We will get the same x value out for both because it's the same intersections where these lines intersect. I am taking this negative 6 and plugging it in here. Cool thing about that is, yeah, we still don't know what x is. Yeah, we've got some simplification here to do. Now notice this is one of those make or break you things. I stress to my students, please make sure that whatever you substitute in, you put parentheses around it because it could affect things. If you didn't put parentheses around that negative 6, it might look like subtraction here. That is negative 2 times y. That is negative 2 times negative 6. All right, and that is equal to negative 12. We do need to simplify first. The only thing that'll simplify there is the negative 2 times the negative 6. That ends up being negative times the negative is a positive, so this turns into plus 12. I like how this one is working out. So if you'll see here, we have no more simplification we can do. So we can go into our solving steps. If we are going to solve here, we're going to do the opposite operation of how the number is attached to the variable. Since we have more than one operation here, since we are doing opposite operation, we need to do opposite PEMDAS as the path of least resistance here. So we're going to undo that addition by subtracting 12 from each side of the equal sign. Those cancel. We are left with negative 4x equal to negative 12 minus 12 means we go deeper into the negative. Those don't actually cancel each other out. They don't have the opposite sign. So we have negative 24 here. And from there, we are going to divide off the negative 4 because it is attached by multiplication to that x. And what we do to one side of the equation, we must do the exact same thing to the other side. Negative 4 divided by negative 4 is 1. 1 times x is just x, so we can write that as x there. All right, and negative divided by negative is a positive, and 24 divided by 4 is 6. And we just found an ordered pair. So you might be one of the students who has a teacher that would count you off if you did not write this in ordered pair form. I would probably shave off a portion of a point there, depending on how it's phrased. But it is important to note that this solution is an ordered pair. It is an intersection on a graph. And just so you have a visualization of what we just found, here is the graph from Desmos. You will see that the intersection of those two lines is 6, -6. Thank you so much for your time.